Hello, everyone. Welcome to today's webinar titled Underground Cable Installation and Conduit Design. Today's webinar is sponsored by Power Delivery Intelligence Initiative, also known as PDI2. I'm Teresa Hansen. I'm the Vice President of Content here at T&D World. And before we hear from today's presenters, I need to go over just a few housekeeping items with you and explain to you how you can participate in today's discussion. First, if you have any technical difficulties during today's session, please use the question window to let us know, and one of our technical experts will help you out. We recommend that you do disable any pop-up blocking software or extensions in your browser because these can cause some issues with the webinar player. In addition, we welcome your questions during today's event. Our presenters will answer as many questions as possible, and they'll be monitoring the questions in the queue throughout the session, so you don't need to wait until later in the session to enter your questions. I recommend that you just go ahead and type them in whenever you think of them, and like I said, we'll be monitoring those throughout the discussion. To ask a question, all you do is type it into the question window on the side of your screen and hit the submit button. Also, please be aware that today's presentation is being recorded and it will be available on the T&D World website within the next 24 hours. You'll be notified by an email when the archive is available, and that email will contain a link to the webinar that you can use to go back and watch all or part of the webinar again. And also, better yet, you can share that link with your coworkers or peers who maybe didn't get to tune in today, but you think they would benefit from today's discussion. The archived webinar is free, and it will be available on the T&D World website for several months, so be sure to pass that on. Now, I'd like to introduce you to today's speakers. First, we have Mike Beeler, who is the National Spokesperson for the Power Delivery Intelligence Initiative, and he is the Chief Opportunity Officer for Mike Beeler and Associates, and he will be moderating today's webinar. He is going to be joined by Tom Fredericks, who is the Vice President and General Manager for North America at American Polywater Corporation. And Mike is also an associate member of PDI2, Tom will be telling you a little bit more about himself shortly. So with that, welcome, gentlemen, and I'm going to turn the program over to you, Mike.
Thank you very much, Teresa. Appreciate that kind introduction, and welcome to today's webinar. We have 1 hour of an outstanding presentation and conversation. We really want this to be conversational with you, the audience, about underground cable installation and conduit design. And with us today is a member of PDI Squared, Tom Fredericks, who is very engaged in some outstanding technologies that are going to help you reduce the cable pulling tensions for your conduit systems and increase the length of your cable pull. So Tom's a member of PDI Squared. What is PDI Squared? The Power Delivery Intelligence Initiative is simply a group of contractors and consultants and vendors and equipment manufacturers that advocate for underground transmission and distribution as opposed to overhead. Not every line will be underground, but many, many can. And we think that planners and engineers and executives and regulators need to start to look at the total cost of ownership over the life of the asset. The total cost of ownership includes the cost of construction, planning, design, and construction. And that's what we're going to talk about today with Tom Fredericks. And Tom is with Polywater. And now, Tom, if you just want to say a quick word of hello, maybe introduce yourself a little bit and say hello on behalf of Polywater.
Sure. Thanks for the introduction, Mike, and welcome to all those who have joined us. I've been with American Polywater for 34 years, and I cover the United States and Canada for the company, primarily electrical in the U.S., but all markets for Canada. What we want to achieve today, our main objective is for everybody on this call is to learn and to understand that we will be able to lengthen your underground cable pulls, to reduce splicing, and to reduce the amount of vaults that you have in your system, which will absolutely reduce the costs of undergrounding. And this will be shown by a live demo at the end of our kind of discussion here with our pull planner software. So with that, Mike, I'll turn it back to you.
And as a civil engineer that has designed underground systems for many, many years in my career, I'm really, really excited about what we have to talk about today. Tell us a little bit. I always wanted to, and I know I'm sure our listeners are looking for ways to maximize those cable pulling distances, and you have done that at Polywater. So tell us a little bit about Polywater. You've got a great proven track record of hundreds of thousands of miles of installations. So tell us a little bit about who and what Polywater is, Tom.
Yeah, sure. I think it's always kind of fun to learn about how companies started. And Polywater back in 1973 started out as a wetsuit lubricant manufacturer. So we made a water-based lubricant that people could put on their skin before they pulled on their wetsuits, which made that process easier. And then they could also slide them off at the end of the day. But how we kind of made the transition into cable pulling in this underground world is that an installer from the local Ma Bell telephone company, Northwestern Bell Telephone Company, got a hold of Nels Jones, the founder of Polywater, and said, hey, could I get a bigger container of this wetsuit lubricant? Because I think it would work great on installing cables into Conduit. And so that person tried it. It worked so well that that lubricant, which was called Polywater A at the time, still is today, spread like wildfire throughout the Baby Bell system. And because the telecommunication companies and the electrical companies share a lot of common vaults and manholes, the electrical utilities saw this. And when they saw this lubricant, they said, man, we would really like to get something like this too. But the difference is their cables are very heavy and tend to be a little bit larger than the telephone cables. So Nels formulated a new product that was a stronger gel, and this became a great success with those companies. So the interesting thing is that these companies at the time were using bentonite clays, whether they were in the electrical utility or building nuclear power plants or big industrials, but bentonite clays that you used like when you were a child, and they would mix it with water as well as soap, like ivory snowflakes, mix that with water to create slurries to pull cables into conduit system and waxes. Because Polywater was so revolutionary, this water-based product, the cable manufacturers increased their awareness on cable compatibility and the concerns with that. So Polywater became a very trusted industry source due to the extents that our company went through testing cable pulling lubricant compatibility, coefficient of friction that we're going to talk more about. And the cable manufacturers really, really appreciated this. So we became active members with the IEEE, the ICC, the OFC, and many other industry organizations to really become involved with underground to help all these organizations improve the lengths of their poles and reduce the tension and sidewall pressure. But today,
and Tom,
yeah.
I'll just interject here too. We got our very first question from the audience. Thank you very much, and it kind of relates to those industry meetings that you mentioned, and I know that we want to talk about what you're seeing at industry meetings. This question is, can you present the kind of installation costs you're presently seeing in the industry, and do you see these costs coming down? And Tom, I think that's the point of this webinar and some of the other webinars that PDI Squared has sponsored in the past, is that we do see these costs coming down. And in your particular case, when you were able to, because of reduced coefficients of friction, you're able to lengthen these cable poles, you're able to extend the cable runs and reduce the number of splices, reduce the number of manholes, you're reducing the civil cost, you're reducing the electrical costs. You want to comment on that a little bit, Tom, and then what you're seeing in some of these industry meetings as you and your team go out to various meetings?
Yeah, sure. I think if you want, you can actually move to the next slide. And this question is kind of perfect timing. I didn't mean to sound like I was prattling on the first question there. But if you pay attention to the news right now, Florida Power and Light has a multi-billion-dollar project to underground all of Miami due to severe storms and hurricanes. Vegetation damage being the major contributor to causing outages and disruption. Duke Energy is doing a tremendous amount of undergrounding. Georgia Power is doing a lot of this to increase the reliability. Also, another big one in the news for this person that sent in this question is PG&E, because of the wildfires, they are doing a massive undergrounding project, for system hardening. But it's other places around the country in middle America that have had mission critical facilities such as data centers. They want to move to undergrounding. And I'll get into a couple examples here in just 1 second, Mike. But the other thing that we should realize is that there is a big beautification phase going on in the United States, meaning moving overhead power to undergrounding. So you have like the California Public Utility Commission with Rule 20, and that's for beautification, resiliency, and outages caused by vehicles. The Champlain-Hudson line, the Sioux line, Northern Pass, these are all massive underground transmission lines moving renewables down from Canada and throughout the United States. So to give you a good example of the costs that are associated with this, you've got many companies who have done a lot of undergrounding for a long period of time, but they tend to use cookie cutter methods. And if you just stay by the, kind of the same old, you're going to be able to not pull as longer distances to eliminate vaults and manholes if you do by using a product like our software, the Riffenberg equations, which are simply going to reduce those vaults and manholes. Mike, the one example I can give that caller, and I guess we'll just skip around on these questions, is that a port authority came to us on the East Coast recently, and they had 300 underground structures designed for their project. After they reviewed the scope of the project, they found out that this was causing budgetary concerns, and they thought it was too many underground structures. By using the pole planner to lengthen their poles, we were able to eliminate 1/3 of those structures. That's a total of 100 structures out of 300. So you can imagine the cost savings alone just in that development.
Right, and I think that's part of the exciting part of this equation for the civil cost and for the electrical cost. When you start to think of the number of splices that you may or may not have, and certainly the manholes on the civil side. So there is you mentioned a number of utilities, Tom. Are these utilities that you're mentioning that are doing these big programs or these big HV, DC, and they're mostly HV, DC transmission lines. Are they using Polywater? Are they using your product right now?
Yeah, absolutely. And, some examples of this is that offshore wind. So offshore wind is a little bit bigger in Europe, and it's going to be big on the East Coast. Part of that is that the West Coast, you need to have floating platforms because it's much deeper in the U.S. But in Europe, they're a little bit ahead of us on the offshore wind. When they bring those lines from offshore onto the shore, they need to run that to a substation. And generally, these substations are not right on the coast. They're inland for quite a ways. So we've been involved with those big projects to offer our expertise on the proper cable pulling lubricant to use to offer the best friction reduction, but also the software to show them how long they can pull. These specialty cable installers, Mike, they are talking about in the U.S. how they want to increase their pulls to 8,000 to 10,000 feet. That's what's being talked about right now. So that's a big development.
That's impressive. That's really exciting because I know we used to have some general rules that we would probably not go more than 2,000, and we were looking at, and I know you're going to talk about this later about how you're going to back into some coefficients of friction, but we make assumptions on coefficients of friction, and we get very, very conservative. And I want you to talk about two things. Number one, if I'm overly conservative, not only is the cost of my underground system going up, but if I have to compete for a data center or for a new industrial complex that might be part of an economic development package that's coming to my community, or for other things that we want to do as a community, where I have to do it on a competitive basis, a new solar or wind farm that's going in, and I want my AE firm to be very competitive in designing the distribution collection system, the underground collection system, I need to be looking at these longer poles. And so I'd say comment on that, and then comment on what you're hearing at these industry meetings. Back to this question, are you hearing things at industry meetings that are leading us in this direction? Are young men and women going to these industry meetings saying, look, we're not going to do it the way we used to. This is the 21st century distribution system. We're not going to design these things the way we did back in the 60s and the 70s, and we're not going to be overly conservative when today we have the data and the technology that proves that we don't have to. That was a long question in this conversation, but
yeah, no worries. And I hope the moderators are kind of looking at the questions. It looks like somebody is saying there's no sound, but yeah, Mike, I think one of the committees that's instrumental in everything that's underground is the ICC committee, which is the Insulated Conductor Committee, the IEEE Power Engineering Society. This committee is only focused on developing and servicing IEEE technical guides, recommended practices and standards for the design, manufacture, testing, operation, and maintenance of insulated cables, including high voltage transmission, which is what you're bringing up, Mike, and distribution cables usually associated with utility power systems, but also commercial and industrial wire. And that's where you get into this data center. And, maybe some of the people on the line don't realize this, but data centers are massive, massive consumers of power. And so the amount of power going into those centers to cool all the servers is incredible. And they also have cooling towers and other things. So their underground services, they don't want any disruption, and they need critical power. By reducing the amount of splices, you provide much more, the power that you're providing is much more reliable than if you have a lot of splices. And so they're looking for the best underground systems to go to that. I would highly recommend that people look into, I don't get paid by this, I'm a member of the ICC, but your major cable manufacturers, your accessory manufacturers, vault and manhole, anything that touches a cable underground are in that organization. There are other organizations for people out there too to not only attend but to participate in that are very utility focused, like Western Underground, Southeast Electrical Exchange, the NWPPA, NEPPA, the MEA. I go on and on and on, but Polywater is a regular participant with these organizations, and they write a lot of papers about it. Secondarily, there was somebody on the call that put in a question about, are there examples of cost analysis? PDI Squared has a lot of information on our website about cost reduction and analysis, but another paper that people could find very, very helpful was written back in 1999 by EPRI, called Underground Cable Installation and System Cost Reduction. And that paper actually addresses the costs of undergrounding, but how you can optimize longer pulls to reduce that. So I would suggest that to one of the callers that called in.
Yeah, I think that's a great point. And I love the idea of being more competitive for these data centers, for these renewable wind farms and solar developments. And a utility, if they want to win in a competitive marketplace, or they want their AE firm to help them win in a competitive marketplace, they need to know and understand these things. They cannot design these distribution collector systems the old way when your competition is saying, well, I'm going to pull to as far as 8,000 to 10,000 feet. That's an incredible length to pull, and for reasons stated. Hey, Tom, what other what other kinds of technologies are out there that you think are bringing down the capital costs? We talked last month with Ditch Witch and Vermeer about their equipment and how their equipment is getting better and more powerful in a smaller footprint and it's able to pull these cables longer distances, right? Oh, and by the way, now you're telling us that you've got the lubricants to pull these cables longer distances. So what are the kinds of technologies do you see out there, or maybe you want to comment a little bit more on this equipment that are going to make this work in our civil construction and our electric cable pulling?
Yeah, absolutely. And we're going to get into some basically some tips or some advice on equipment and whatnot here in just a little bit. But everything today is built more robust. That's what everybody on the line should understand more than anything, meaning cable manufacturers are building their cables to be more robust, to add more reliable energy to their customers. So that means you can pull longer distances with this cable. They're designing cables to go on larger reels so that you can pull longer distances. Cable pulling machine manufacturers like Conduit, Sherman and Riley, and others, they have developed machines that can handle pulling cable longer distances because they can handle higher tensions. If you look at all of this, and then you look at the cable accessories like shivs, pulling eyes, winch lines, everything can handle higher tensions. So the problem today that we see when we go in and talk to engineers, or the opportunity to be more positive, is that there has been a big loss in a lot of veteran people throughout the industry. There's this knowledge vacuum, and many companies continue to use kind of cookie cutter specifications, which can limit them to achieve cost savings. So if you want to continue to do things the same way, you got to realize that everything today is more robust, which allows you to install cable underground and reduce your costs. That's the big thing.
So you want to give us some tips on various parts of the whole process of planning and design and construction and ultimately cable pulling. You've got some tips that I think that you wanted to mention to the audience and see if they've got any questions along those things. One question that did just come in was, okay, if you're going to pull 8,000 to 10,000 feet, what kind of cable are we actually talking about? I mean, does that amount of cable even fit on a reel? I think is a reasonable question. Or, does it fit on a reel that can actually be transported over public bridges and things like that? So, what do you think about that, Tom?
Yeah, I mean the cable designs and reels for some of these longer transmission jobs that have been done out there. These custom installers, there's some companies out there like New River, for example. These guys live and die in underground. That's what they specialize in. They pull massive, long transmission pulls, things that nobody's ever done before. And so what they do is they end up modifying or designing their equipment to fill these reels to pull these distances. So again, the work with the cable manufacturers and these installers are key. Some of the cable manufacturers have their own installation crews. And so these are the people that the person that asked that question, if they're looking for such people or resources, they can shoot me a message, and I can certainly tell you about that. I think, Mike, your question, if we kind of break this up, and which this kind of goes along with what they were saying, is that if we first talk about design, we have a project, we want to design it. Again, I said this earlier, but the key is today is to not rely on the same old designs. And I'm going to show you with the software here in just a little bit of if you pull from one manhole to another manhole every 500 feet, and that's where you're going to do your splice, or that's where your setup time is, and that's the way you've always done it, and that's the way you're going to continue to do it, I can't help you. But what I'm going to show you today is how far you can pull through those manholes so we can eliminate 3 splices or eliminate the placement of manholes. So design is very, very important. And if we can eliminate vaults and splices and pull longer distances, another thing that people benefit by that is that if you are a utility and you are pulling down the main street of a city, you've got to hire traffic police. There's disruption to traffic. But if you can get in and get out quicker, sometimes your permitting drops, your disruption drops in the city, and of course your costs drop. So that's another benefit by designing your pulls the right way. Another thing that people take a look at is if you just take a look at in design in general, again, kind of the same old. A lot of people used to use PVC underground, and they would use a galvanized rigid steel sweep to minimize burn through from pull strings and some cheaper ropes. But companies now are specifying fiberglass sweeps because they're lighter, they offer a lower coefficient of friction, and they're more robust in numerous types of environments. So whether it's a wastewater or coastal environment, any kind of caustic, they just do much, much better there. If you can just kind of skip ahead 2 slides, I just want to make a point here. It's the hidden damage. Yeah, go ahead, Mike.
Yeah, well, I was going to comment too, because we had a question that came in from a public service commission that's kind of right along the lines of what you're talking about. And the question is, hey, I'm overseeing a large statewide distribution reliability initiative, and is there any way to minimize the increased costs and delays incurred when unknown items like rocks and trash and stuff like that are encountered, which tend to, he's suggesting would increase when you have longer pulls. In other words, you're going to have a longer pull and you're going to get into things that maybe you hadn't anticipated. And I would say, I would answer that, Tom, and I'd love to hear your answer. I think you kind of already answered it, is that engineers today need to be more engaged in the specifications that they write. Hey, sometimes you're going to need to put in fiberglass elbows. Sometimes you're going to need to, do greater research on what some of those underground obstacles are going to be, and you're just going to have to go underneath them. Maybe you use a directional drill. With today's technology, use a directional drill to go underneath them. But you need to be specifying the right kind of pull cables and such. You need to specify and use the software that you're going to talk about later, but you need to specify using a lubricant and know what the coefficients of friction truly are. So you want to comment on that for somebody that, from a commissioner's, from a regulator's perspective, they're overseeing a large program and they're looking at some of the things that we're talking about today. Do you have any comments along those lines, Tom?
Yeah, and Mike, I think you hit the nail on the head. Again, if your spec just states that you need to install cable from A to B and you leave everything up to the installer, that's where problem happens. So to specifically answer their question, after the installation of the underground system, depending on where you are, sometimes one contractor installs the duct, but then the utility comes back and they do the cable pulling, or you might have a different contractor that comes in and does that. So a good rule of thumb, if they're worried about that, is you need to spec out in your job that all conduits need to be proved out by running a test mandrel through them prior to cable pulling. And mandrels are this hard block of wood that are shaped in a cylinder so that they go through the ID of the conduit to make sure that nothing has happened to that duct system during the install or the backfilling process. So again, there's a lot of cable guidance out there through these organizations that talks about what type of backfill that you need to use. Even how level or how the excavation of these conduits go. But, whether you're just doing 500-foot pulls and then another 500-foot pull, there is no difference when you're removing all those rocks and whatnot. The difference is what you put in your specifications to make sure things are installed properly.
And I'm going to comment too to this regulator in this state because I'm familiar with what's going on in your state, and this is a massive program. You're going to spend billions of dollars on it over the course of many, many years. And it is incumbent upon the utility engineers or their consultants to have a good specification, and for those engineers to get out into the field. And Tom's going to talk about this later, especially when going back and looking at real coefficients of friction after the cable's been pulled. But to write the specification, to make sure the specification is enforced with your inspectors, and to do it the right way, because this system is going to last for a long, long time. And a lot of your distribution system of the future that is going to need to carry the reimagined grid, or the grid of the future, and all the initiatives that we as an industry are trying to do with electrification, it's going to have to be in great shape. You're going to have to make sure that you design it and install it correctly. And so that is incumbent on the engineer. And so young engineers, men and women, you must write the specifications and then get out into the field and make sure that the specifications are in fact delivered by your contractors. Okay, Tom, back to you after that soliloquy.
Yeah, no problem. I mean, design and planning, they're kind of one and the same, but probably within the next 10, 15 minutes, I'll be showing everybody on the line how you can use real world cable pulling that's occurring on your projects right now to effectively back calculate your coefficient of friction to show you how far you can pull. So the key, again, when everybody is on this call, is that if we design and plan the underground system, and we've not doing the same old, and we're using good resources. If you calculate the ending tensions and sidewall pressures on your cable pulls, then you'll know if it's better to pull from A to B or B to A as an engineer. Well, that needs to be put in the plan so that the installers don't exceed the ending tension or sidewall pressure. Because if you don't do this ahead of time, you're going to leave room for error, because installers and crews oftentimes will choose whichever way is better to set up their equipment, not necessarily the best way, to pull. And this way you're going to maximize those pulling distances. Another item is that installers, they're not aware that cables have a maximum ending pulling tension or sidewall pressure. So if their job on the ticket is just to pull in from A to B, then they will go get their backhoe or a delivery truck or something else to pull in that cable, because that's all they're told. And as long as they get that cable in from A to B, that's what they're going to do. So there's a lot of things, that you can do to help out. And there are really good resources for everybody that's on the call right now. And that is from companies like Prysmian, Southwire, Okanite, Keyright, and others. They have excellent installation guides, which will cover minimum bend radiuses that their cable can handle, positioning and handling of their reels, cable specifications. They just have a lot of great direction in there, and those guides are free. Again, if you need some contacts, I'd be glad, to point that out to you. You want me to give a couple other, Mike, or is there something else?
Well, I got a couple. We just got a couple of great questions in from a couple of people from utilities, and they have to do. One has to do with the life of the conduit system, and you've got a lubricant in there, and so you go back into that conduit system maybe 15 or 30 years down the road, and can you expect that conduit to have the same kind of coefficient of friction? And related to that is, if you're installing a conduit system, and if your lubricant is pre-installed in the conduit and it's already there, but then you're coming back several years later, how long can that last if it's pre-installed in the conduit? Maybe you want to comment on that and the longevity. I know you're talking about this down the road a little bit here too, but a couple of questions that just came in.
Yeah, sure. And I'll try to be short, but again, if people want more information, they can talk to us. Okay. So there are some conduits out there that are called pre-lubricated conduits. Generally, they're more in the telecommunication industry, but what they help with more than anything is to help reduce the friction with the pull tapes and the pulling lines, because the heavier the cables that you have, the amount of cables you have in your system will increase the rub. And so a lubricant, no matter what, is always going to be your very best defense against friction. Now, polywater cable pulling lubricants, when they were invented, remember back in the beginning of this, Mike and everybody on the line, I talked about how people use bentonite clay, ivory snowflakes, and wax-based lubricants. Again, we keep reminding everybody, you want to improve your performance, reliability, reduce your costs, check your specs out, review them. Those lubricants will leave over a 20% residue in the conduit system. And that's what cements your cables in at a later date. Polywater lubricants leave less than a 3% residue, and they essentially dry slippery, or there's nothing in there. So when you talk about cable removal, we've got a bunch of techniques. If you're in, like, let's say, the old Orangeburg duct that swells, we can give you tips on how to remove your cable there. We can talk about how if you've got longer runs and you want to help reduce that lubricity, you can. So the fact that polywater doesn't leave a high residue and it's essentially slippery, that's what's going to aid on the removal of your cables versus other lubricants out there that have such a high residue. How's that?
That is a great answer, and I think that addressed what these people were asking very directly. Thank you, Tom.
Okay, sure. Just a couple more things, and Mike, you brought this up. A general rule of thumb for everybody on the line is that this is something that everybody can remember. So in your specs, if you just say use a cable pulling lubricant, remember the lubricant is the most important part of your job. It's the least expensive product on your job when you talk about the cost of cable, conduit, and labor. So if you write down in your specs that 1 gallon of cable pulling lubricant should be used per every 100 feet of cable installed, that's something everybody can remember. And that's a starting point. That should be increased as up to at least 25% if it's an old existing conduit system, or the conduit's filled with water, or you've got lots of bends, or you've got heavy cables. But that's a good one for everybody to remember. One really important thing that we want to get back to on the cable pulling equipment, and when that person was talking about that increasing your pulls 8 to 10,000 feet, the best thing that you can do on your specifications, and the government, we see this a lot on government jobs and with other high-end engineering firms, is they require the installers to provide the ending tensions at the end of a cable pull. That's super important, because that information, when they hand that to you, is the best way that you know that that cable was installed without exceeding the ending tension or the maximum sidewall pressure. So again, beefing up your specs, writing these things in there is going to be great. That's going to be wonderful. Just some other quick tips for everyone out there. Winch line versus ropes is preferable. Winch lines don't stretch like ropes. If you are going to allow ropes to be used, make sure you spec out a double braided rope, because just plain old ropes will surge, they'll stretch, and that will cause your cable to surge and stretch in the conduit. There is an IEEE paper on this subject. I believe San Diego Gas and Electric was one of the authors on it. Recommending pulling eyes is also another great way to reduce tensions, and to, when you're lengthening your pulls, they can handle more ending tension than grips. They also don't cause as much rub in the conduit. Speccing out pulling tapes versus poly lines will cut down on your rope burn through. And if you are measuring out ending tensions on cable pulls and you're an installer on the line, and let's say you're going to come in at about 4,800 pounds, it's a good idea not to use a 5,000 pound tugger on that pull. You should try to go to a tugger that could do at least twice the amount of the predicted tension. That way you're going to have a much more effective pull, because you're not going to be maxing out that puller. Some new technology out there is the use of cable pushers or cable feeders. And these simply are kind of like a set of rubberized tank tracks or rollers that the cables go through that help feed the cables into the conduit system, which eliminates back tension. At the very least, please instruct your crews to feed the cables into the conduit, especially if you start out with a 90, because that can greatly reduce your ending tension and sidewall pressure on the pull. So those are just a few of the tips and tricks, Mike.
Those are some great tips, Tom. Thank you very much. We got about 20 minutes left. I know you want to show a video, and I know you want to show your software that you're going to give to everybody that attends this webinar free of charge. So why don't we shift into a discussion of coefficient of friction? And we did get a question, can you confirm 1 gallon per 100 feet of lubricant for a pull? So talk about coefficient of friction, maybe confirm or deny that, and let's maybe see your video.
Yeah, so let's combine all these friction questions, Mike, together. I'll address them all, and then we'll watch the video so that people can basically see how we measure that. Okay, not to sound like a commercial, but you can go onto our website, and there's a free calculator. It's very easy. You put in the ID of your conduit, like 4-inch. You put in the length of your pole. Let's say it's 2,000 feet, and it multiplies that by 0.0015, and that tells you the amount of lubricant that you need on the pole. The one that I use, it works out when you do that. Just go ahead and try it for yourself. You'll see that it turns out to be just about 1 gallon per 100 feet. Why I suggest that is because installers, they can remember that. It's just easy for them to remember. And what everybody on the line needs to understand is that when you pull a cable dry, or you don't coat the cable properly with cable pulling lubricant, you are essentially installing and putting that cable into a conduit like you don't have lubricant. So if you don't use enough lubricant, if you don't coat the cables properly, you're essentially going to raise the friction between the outside of the cable jacket and the conduit surface. So that's what coefficient of friction means. It's basically a cross-link poly, a linear low density polyethylene, a PVC jacketed cable are all going to have different coefficients of friction in a PVC duct. They're going to have another set if it's in a polyethylene duct or a galvanized rigid steel duct. So let's kind of just talk about one thing here about coefficients of friction, because I think it probably would be best to show the video very quick. It's only 1:50, and then I'll do the live demo so we have time. I'm going to talk about what the cable manufacturers recommend for the coefficient of friction. And so we'll do that in the software coming up. But if we could just show that short video, this will give an audience a really good understanding of how we test and how accurate we are measuring that frictional force. And then I think, Mike, we should probably just try to kick right into the software.
High-performance cable lubricants are specially engineered to reduce frictional forces between the cable and the conduit or duct wall surfaces during a cable pull. Optimal friction reduction allows for longer and safer cable pulls. To maximize a cable pull, it is important to have accurate friction values. Engineered cable lubricant manufacturers conduct comprehensive testing using a variety of methodologies to analyze friction and tension between different cable and conduit material types. The friction table is used to test a variety of conduit and cable jacket combinations. Short pieces of cable in conduit are used in this test. The sidewall cylinder applies a normal force to the cable. A load cell measures this force and feeds it to the scale. A pulling winch moves the conduit at a constant speed. Pulling force is measured by a second load cell and fed to the scale. Forces are measured simultaneously. Pulling force is divided by the normal force to calculate friction coefficient. Proper lubrication typically reduces friction by at least 50%. The multi-bend device pulls cable through a series of bends which rapidly increase tension. Back tension is produced using a pneumatic pressure brake and is measured with a load cell. The pulling winch pulls the cable through multiple bends. Pulling tension is measured with a second load cell. back tension and pulling tension are used to determine the friction's coefficient using a standard formula. In the Telcordia reel test, a continuous duct is wrapped around a drum to create 420 degrees of bend. A fixed back tension is attached to a pulley. The cable is connected to a load cell and pulled out at a set speed. Dynamic tension values are recorded as the cable moves through the conduit. Pulling tension is used to calculate the friction coefficient using a standard formula. The Telcordia test is a good way to test lighter weight communication cable. For more information on testing methodologies or additional resources, contact Polywater.
Okay, let's answer the last question, and I'll pull up the that information. There's one question here about deep direct bores for retrofits and high-density city installations. To give you an example, there are absolutely improvements in directional drilling and deep bores. This one here was almost a mile long. This is a little bit different than a city, but when you're talking about this area, again, PDI squared has a lot of information that you can get from this, Stephen. But this particular bore was HDPE in a steel casing a mile long. With the use of the pull planner, Polywater came within 28 pounds of the ending tension using some good data. But hopefully that answers your question. So deep bores are a common application these days.
Yeah, we appreciate all those questions we've been getting. And Tom, I think you want to roll in and about the 10 or 15 minutes we have left, you want to talk about your software.
Yep. All right. So I'm going to give a quick demo, but just so everybody understands on here, essentially, have your email. We'll be sending you an email that will give you a free download, the password for it. But if you want an in-person training, it's absolutely free, or a webinar training, we can do that as well. So I'm going to roll through this pretty quickly, but I want to show you how you can achieve longer pulls that eliminate splicing. So I'm going to do a quick underground deal here. So essentially, when I open up the software, you can name the pull, which I called PDI squared presentation, and then the description. So you can be as descriptive as you want, Maple Street manhole 7 to Pine Street manhole 12. So when you enter the conduit in inches, if it's a 4-inch pipe or a 5-inch pipe, you can just put in 4 or 5. But when you put in the cable diameter, make sure you put in the actual reading that you're taking from the spec. Don't round up or down because that could affect the cable pull. If you've got an intern or you would like to put in a whole bunch of your cable information, so if you've got a large underground project where you've got tons of 15 kV cable or 750 kc mil, you can put that in the database, and rather than enter the outside diameter of the cable, which today I'm going to do a 750 kc mil cable. It's 1.27 OD, and this is found in your specs. And in there, this cable weighs 2.66. So now it's asking you the number of cables you're pulling in. So we're going to pull in 3 into this conduit system. If you had a ground or a neutral, or if you were doing a job where you had a bunch of control cable, and let's say there was 4 different kinds of different size cables, you just simply put in the cable, then its number of cables will be 1 and continue on. In this example, I'm going to put no. Then we come into the lubricant. So these are Polywater lubricants. NN was specifically designed for underground transmission, pulling through water. It is just a phenomenal lubricant. LZ's for low smoke, zero halogen. Probably most everybody on the call today is familiar with Polywater J or PJ. So we're going to say we're pulling with J in a PVC duct, and we're going to have linear low density or LDPE cable. Now, you can see the different lubrication here is 0.11 with Polywater J, but dry or unlubricated is a 0.43. Cable manufacturers typically recommend using a 0.35. So I'm going to get to that in a minute, but you simply click on the box with the lubricant and you see that it populates here. And remember, that's you just saw a video. That's how we measure it. Now, back tension. An example of this would be that you have a utility pole, and for whatever reason, you need to go up and over the pole and down the riser conduit down into the ground. If your weight per foot weighed 10 pounds per foot and you had to go 20 feet in the air around a bull wheel to go in that conduit, you would have 200 pounds of back tension. If you've got a brand new reel of cable, meaning it's filled to the gills and nobody's going to help move that, when that tugger starts up, it's going to take effort to pull it off the reel. So for right now, let's put in 0, but I'm going to show you how back tension greatly affects the ending tensions. Okay, this review right here essentially tells you what your conduit fill is. So you can look at the NEC code or your own requirements. It tells you the cable configuration is cradled, so you can take a look at putting in an upgrade maybe for a customer in a few years, like Mike was talking about at a data center. And then jamming clearance. Jamming is only calculated in the software and with the mathematical formulas for 3 cables. It doesn't do it for 1 cable or more than 3 cables. So that's all we've done. So again, I'm going to move along here. So now we need to put in the raceway run. So I'm going to say that we're going to be pulling down in to a vaulter manhole. So we're at 90 degrees from horizontal. We're pulling down that raceway system. And from the top of the reel to the bottom of that conduit, in this case, we're going to go 10 feet down. And then you can see that you've got these choices. So for the gentleman that asked about those big bores and long radius bends that happen with bores, we do the calculations that. So that would be for a bridge crossing, or that would be for going underneath a river or a bay. There's lots of applications to use this. And of course, we have the push-pull device that I told you about. Here, we know that we're going into a vertically concave up bend. We're pulling down through the bend. It's a 4-foot radius. It's 90 degrees. We're going to add our next segment. So let's say we're going to do the same old, and we're going to go every 500 feet, and that's where we splice. But we want to see how many vaults we can go through. So let's just do a system that I cooked up here. So we're going to go 500 feet, and there's no bend. So we went down in the first manhole. We went 500 feet out, and that's where you would normally splice. And what it tells you is what the tension and the sidewall pressure is. Now you have negative tension here because you're pulling directly down into the vault or a manhole. So we're going to go 0 degrees. I know we had a lot of good questions, so we're going to really rip through this. Okay, so we're going to go another 500 feet. And then here, we're going to come in and we're going to say that we have a roller because we're going to turn because we were on Maple Street and we're going down to the other street. Now, the roller add-on tension, again, we don't have a ton of time, but this is usually between 75 and 200 pounds that you can put in, because essentially when your cables are going around a roller, they're not getting friction, but they are getting a sidewall force there. But the tension is kind of easy because it's rolling in there. So if we go another 500 feet and we have no bend, we can see that now we've gone from 1, 2, 3, 4 manholes. And at this point, we're only at 2,339 pounds, and we've got 276 pounds of sidewall pressure, and our total pull length is 2,000. So again, if we did the same old, you're going to have 1, 2, 3, 4 splice points, where now you have 2. We've reduced 2. You could also take a look at removing those vaults or manholes if you wanted. Now, the cool thing about the software is based on the Riffenberg equations. That's the mathematical equations that everybody uses. So let me show you why you came today. If you reverse the pull, it's always better to get rid of your bends first, go through your bends first, because the weight of the cable, you have less weight of the cable going through. And you can see going the opposite way is just much more difficult. So let's show you why you came today, because we're right at 10:55. Remember, we told you that by far the most accurate way to predicting future tensions, especially if you were pulling in an older existing conduit system and your contractor is going to provide that. When the head end of the cable comes out of the ending conduit system, that's when we want them to read the tugger. Now, we used a coefficient of friction of 0.11. Let's say you didn't know what to put in for back tension. We predicted 2,339 pounds. Let's say in the field, you click on coefficient of friction backward calculation. You click in this box. Let's say that they had 3,500 pounds. When you click this, this tells you that your coefficient of friction that you're experiencing in the field is a 0.17. Why is this revolutionary? Why is this so important? Because as you measure, as you ask for that contractor to give you that data, over time, especially if you're a utility, you can analyze crews, because the numbers should be coming closer to the polywater number, the 0.11, and we've got lots of information on that. But maybe because it's an old conduit system and they can't quite clean it out, it's not level, whatever the situation might be, now you know that if you back calculated 4, 5, 6 pulls and you were always coming around to 0.17, you know that that's a safe number to use to calculate all your future pulls. That is the absolute power of this software. And Bechtel and other companies have used this time and time again to save money by lengthening their pulls out in the field. So, Mike, I don't know if any questions came up because I'm looking at my screen, but I know we're at 10:57. So.
Well, we got a lot of questions, and I think you've answered most of them. I mean, there's some great questions. We really appreciate it. You know, at the end of the day, you said the word, Tom, as you wrap up, revolutionary. And we need planners and engineers and men and women that are writing specifications for underground systems today and their regulators to know that there are some revolutionary tools out there today in 2022 that, weren't around in the 60s and 70s and the 80s. And we need to challenge our standards engineers to address this as we design the system for the future. So, Tom, as you wrap up and say goodbye, why don't you give some concluding remarks? But that word revolutionary, I think, was really key to me.
Well, thank you. Just a couple other quick things. You can put in your maximum sidewall pressure and your maximum tension, which will flag the numbers as they come up here. Again, because of the robust discussion, I really appreciate that. All I would tell everybody is that nobody can argue with back calculating your field effective coefficient of friction. That's why it's revolutionary. When you can use real world data to then plan your future pulls, you absolutely can reduce your costs and improve your reliability. It's just a wonderful thing. And Polywater has just been very grateful to be a part of PDI Squared and lots of other industries. We really enjoy your questions. And again, if anybody has any questions, please send them to us. Otherwise, you'll be getting an email from us with the download and the software. But again, we can come into your building or do a webinar to really show you some more examples so you can get very familiar with it, because we want to help you make a difference. That's really what Polywater wants to do. We want to become a trusted ally.
Well said, Tom Fredericks. Appreciate that very much. And on behalf of the Power Delivery Intelligence Initiative, we're really proud to offer this to you today. I love the word revolutionary. I love the message that you've got for engineers that are going to be out designing these systems, especially when we know, as that one regulator said, that we've got so much of it to do in the future. So with that, again, on behalf of PDI Squared, thank you very much for listening. And Teresa Hansen, back to you.
Thank you, Mike. And thanks, Tom. That was a great discussion, very informative, educational. I myself learned a lot from it, and I'm sure our audience did as well. And I do want to thank our audience for participating, sending in all those great questions, for tuning in today. We know that you're busy. We appreciate you taking the time to be with us. And on behalf of TND World, I want to thank PDI2 and Polywater again for sponsoring and putting on this webinar. With that, I just want to remind you to be on the lookout for the email that contains the link to this webinar, as well as an email from Polywater with some of the information that Tom mentioned. So be on the lookout in your inboxes for those. And again, feel free to share those with your peers who maybe weren't able to attend today. So with that, that concludes our webinar. Again, thanks to everyone, our presenters and our audience, and have a great day, everybody. Goodbye. Goodbye.